One other property of the soil, which is considered to be a physical property, is soil color. Now, when we first examine soil color, I think we want to look at what are the different parts or components of the soil that have a very dramatic effect upon soil color. Well, the major portion of that soil is indeed the mineral matter. And we know that minerals go through a series of weathering in the soil environment. As they weather, some of the elements in there oxidize and impart specific colors to that soil. These minerals have a relatively high content of iron. As iron oxidizes, it imparts the reddish, yellowish colors, in some case, depending on the degree of state of oxidation, into that soil profile. So when we're looking at soil color, it's a reflection of certain types of ions or elements in the soil that have become ionized or oxidized and impart certain colors. Aluminum has a tendency to impart bluish-gray colors. I mentioned iron is imparting yellowish, brownish, reddish tones. In some areas, there's enough deposit of copper, and as it oxidizes, it imparts this bluish or bluish-green coloration to the soil. So the type of minerals present will definitely affect soil color. The color of the soil and the surface is also affected greatly by the amount of organic material in that soil. As we see an increase in organic matter, we will see a darkening of the soil. This typically occurs at the topsoil or the surface horizon. We impart or we relate this dark color to being a soil that is quite productive. And to a certain extent that's true, but it's not always going to be true. The reason that the organic matter imparts the darker coloration to the soil is that as it decomposes or is being decomposed by these microorganisms and it gets down to a very finely divided state, it is turning a darker color. And this is coming from what is called the humus portion of the soil, organic matter. So humus, which is really a product of the breakdown of organic material in the soil, but it also consists of the living microorganisms as well, will impart this dark coloration to the soil. It actually coats the mineral particles and causes them to become darker in the soil profile. So therefore, we typically look at the topsoil. We see it being darker than the subsoil because of this higher organic matter content, and consider it to be a more fertile type of, or at least a more fertile portion of that soil profile. And in a general sense, that is true. It will be more productive, partially due to this higher organic matter content, and also partially due to a greater degree of oxidation and weathering of some of the minerals that are in the soil. So how much can we really tell from a soil by its color? Well, in an earlier lab for this course, you were asked to take the soil color charts and go through and classify soils based upon their color by utilizing these charts. And I think you can see from that exercise that it's a matter of interpretation, depending upon who that person is that is classifying that color. And probably more than anything else, soil color is used from a taxonomic or classification standpoint more so than from an agronomic, horticultural, or direct applied aspect of soil's ability to grow plants and produce. So for that reason, we're not going to spend a great deal of time on soil color other than to let you know that it does change dramatically from one soil type to another. And if we look at what's causing those colors in the soil to develop and express themselves, it's going to be some combination of oxidation of minerals and mineral content in the soil, and that's going to be tempered or offset to a certain degree also by the amount of organic matter as related to the humus fraction of that organic matter in the soil. Now, one other obvious thing that affects color is the moisture content. So if you were trying to classify a soil based upon color using the charts, it's important that you're comparing these different soils at an equal moisture content. And so for that purpose, we would also want to use oven-dry soils for the purpose of determining color. Most of us, if not all of us, I'm sure, would know that as the soil gains in moisture content, it becomes darker in color. what we may not all realize is why that is, and the reason for that is that if we increase moisture content of that soil, we are getting a higher percentage of the light striking that soil surface being absorbed and a lower percentage being reflected. Thereby, if we have less reflected light, we're going to have what appears to us to be a darker color. And that is why, as we increase the moisture content of the soil, that soil, any given soil, will naturally become darker because it becomes a better absorber and a poorer reflector of light, is what causes that darkening of the soil. To finish this unit up, I want to talk about soil texture and soil structure and the influence that these have on other physical and or chemical properties of the soil. Soil texture and structure have a very great influence upon the water relations in the soil. There are 2 chapters on soil water near the end of this class that we'll be talking about in detail. For now, I want you to realize that as we increase the size of the particles in the soil, meaning we get higher percentage of sand and lower percentage of silt or clay-sized particles, these soils will be reduced in terms of their water holding capacity. So soil texture has a very great influence upon the ability of the soil to hold water against the pull of gravity. And not only do we have less pore space in a coarse textured soil, we also have much larger pores. And since water is being retained in the soil against the pull of gravity due to its attraction for the soil particle surfaces, these coarse soils do not have as much surface area in them, therefore they retain less water. Finer textured soils have more surface area per unit volume. They also have a greater percent of pore space or greater porosity, and for both of these reasons they will naturally retain more water against the pull of gravity. Water holding capacity is not the only important soil water property we're concerned about as related to texture and structure. We're also interested in the water intake rate. The intake of water into a soil is not a function of pore volume, but more a function of pore size. So we can see that soils that have larger pores, which of course are the coarser sandy texture soils, have a more rapid intake rate for water. But they don't hold as much water per given unit volume. So we sacrifice holding capacity for an increased intake rate as we see the soil texture becoming coarser.